The ion-propelled Dawn spacecraft is one of our emissaries that has rendezvoused with 2 asteroid belt objects in its multi-year mission.
The Dawn mission is one of NASA's Discovery Program missions that launched in September of 2007. So it's had a long, circuitous journey from the Earth, flying past Mars and out to the asteroid 4 Vesta, where it spent a year orbiting this small rocky object and mapped its surface and determined its bulk composition and geological aspects of Vesta before leaving the gravitational field of Vesta and traveling for another 3 years out to the dwarf planet Ceres.
Before the arrival of the spacecraft Dawn at Ceres, we were expecting an inert rocky body.
Instead, they discovered a world of mystery and surprise. Dawn has been orbiting Ceres for more than 2 years now, providing us with fascinating views of an alien world. The mysterious bright spots on Ceres appear to be salts deposited on the surface by subterranean activity. Support for this theory can be found in another feature of interest, the bright mountain named Ahuna Mons.
We have looking in detail about the shape of the mountain, and we have compared with what we know from volcanic constructs, and we have found that Ahuna Mons' shape is very similar to that of a volcanic dome that is built by very viscose material.
When we saw Ahuna Mons, we saw that its shape was very tall. It was very tall and had steep slopes. And that reminded us of certain places in the solar system, including Earth and Mars, that had domes that were formed by volcanic activity of very slow-moving, thick material. However, on Ceres, the temperatures are so cold that the same type of magma on Earth and Mars just can't exist on Ceres. So we then concluded that the magma, or the material that's flowing on Ceres, had to be composed of mostly very salty water that would flow at the low temperatures of Ceres. And when exposed to the surface, when they were pushed out onto the surface, they would freeze and form this steep-sided dome. Ahuna Mons is unique in the solar system. There's no other place in the solar system that has a structure that matches that of Ahuna Mons, and it has to be formed by cryovolcanic activity.
Scientists at the German Aerospace Center have used stereo images to create a global digital terrain map of the dwarf planet. Another surprise, a study published by lead author Norbert Schorghofer shows permanently shadowed regions at the North Pole. These are expected to be cold enough to accumulate water ice over long time spans. Future spacecraft visiting Ceres are likely to find freshwater ice there.
So right now we are not only learning about dwarf planet Ceres, but also about planets and small bodies in the outer solar system, like Pluto and its moon. And so we are in a phase in space exploration where we are learning about a new class of objects. And we are seeing that these objects are surprising, as they have recent features on their surface. These observations tell us Ceres was active in the recent past and might be even active today. And this tells us the importance of sending a spacecraft to a dwarf planet to have a close look at the surface, as we are learning new things that are unexpected.
Dawn is now orbiting only 386 kilometers above Ceres, which is closer than the space station is to Earth. And it will continue to return spectacular views. One of the key technologies that made Dawn such a success was its ion drive.
Ion propulsion allows us to undertake missions which would be impossible without it. There have been previous missions and tests of ion propulsion to validate the basic technology, but Dawn now has made it a reality. Dawn's the only spacecraft ever in more than 58 years of space exploration to orbit 2 extraterrestrial destinations, the last uncharted worlds in the inner solar system. And it not only allows us to get to these distant bodies, but once we're in orbit, we can maneuver extensively in order to get the best possible science that we can from the mission.